Hey, afternoon Jimbo, welcome in. Hey David. We're going to be... Oh, now I've got audio on both. Let me just mute the monitor. I'll have to mute my CRT to be honest. You go from one stream having no audio and the next one I've got audio coming out of both. Actually, I think... No, I'll leave it on that way, I don't want to mess again. We are going to just test. So I made a product called the Mega Drive Clean Power the other day that fits in this and gives it... sorry, I called it the Mega Drive Clean Power. The Mega Drive Clean RGB. This has actually got a clean power in. And the point is it outputs RGB, perfect RGB out the back. I designed it for the Mega Drive 2. We've tested that and it works. And then I've realised this will probably just work in the Mega Drive 1 as well. So even though this actually says MD2 Clean RGB, I just want to test on the Mega Drive 1 that it works first. And then if it does, I better rename this product, because at the minute it's literally got MD2 Clean RGB written on the product, so we'll just change it to Mega Drive if so. Hey, welcome in Mark. We're just going to fit, you probably saw the last one, this little Clean RGB into this Mega Drive 1 and test if it does work or not, basically, on Mega Drive 1s. So I'm just giving this a quick test first to make sure the console works, so we've got no other issues. Yeah, this is trippy. I've got the CRT with no lag, and then the audio coming out of the stream at the minute. That's confusing. Oh no, I forgot how hard it is to get backup banks with Sonic. Fastest hedgehog in the world, but can't go up a bank. Oh yeah, this is our long-standing test Mega Drive. Wait till you see the inside; it's even worse. This is just used for whenever we're repairing Mega CDs for customers. This is our little test unit. So inside it's got like test switches and it's nice and ragged, but it's the one we know works fully, so we always use that. Yes, it will be. I don't even know what day we're on. Friday, yeah. I'll still do Saturday and Sunday, but yeah, I'll be off Monday for a week. So I'll be back on the Saturday after. There we go. Converter for HDMI, yeah, you can do. I think we offer a HDMI on this one. But yeah, you can convert most. We'd recommend converting really RGB. Convert the console to RGB like we're going to do, and then use something like an OSSC or any converter from RGB to HDMI. And then if you want to use it with an actual CRT, you can. Whereas if you HDMI mod them, then you can't really get good quality in the original CRTs as well. You're stuck on composite. Right, so that works. We will now turn off the flickery overlay. Turn that off for now, we shouldn't need that. And all we want to do is test if this Clean RGB works. It should do, shouldn't be an issue. So here's the insides of the lovely test console. So you can see we've got, these are all bodge wires from the factory, this isn't actually us. We've got the Z80 socketed because we've used that on another console. We've just got a clean power, so we've actually got USB-C. Not bothered centering this one. Can't actually focus for that high up, but got the USB-C there. Then we've just got little switches we've just dabbed on here, and a little silk screen telling us that basically if we want this console to be a Jap console, we flick this over to the left, or right as English, and then the bottom one, if you go to the right it's NTSC, and if you go to the left it's PAL. So you can just quickly toggle this into any region. So we can use that to test RGB on frequencies as well, I guess. But what we want to do is, let's just get this out of the cage. Get this out of the way. We want to try and install this. So this is basically the same chip as the Mega Drive 2, but just physically bigger. So this is the DIP package one. For Master System, we do the Clean RGB. Not sure on prices off the top of my head, but it's on the website. you'd want the clean RGB option, and then an OSSC on Amazon's like £100 and something basically. So it isn't cheap to do to get HDMI, but obviously you can do. Why does every console we pick up have a hair in it? Don't even know whose that one is. Right, so this is the video chip. So it's got the same pinout. So we'll have, I think it was ground at the top, red, green and blue in, and then red, green and blue out. I'm pretty sure. We should probably double check, but going off the top of my head, that's what it is. Oh yeah, the irony is as well, 90% of these caps aren't even needed. It's the most ridiculous recap when you do it. These are just all absolutely crazy. Like, you can genuinely cut all these off, put 4 on for the video output, and this entire system works. One of the most overkill on them. Right, so yeah, pinout on this. So it's the CXA1145. I'm 99.9% sure that is the same chip. It's just a different package. Let me just check. Yep, exactly the same. So we've got ground at the top, red, green and blue in. Then we have 5 volts at the bottom corner, and red, green and blue out. And if we pull up the schematic as well, let's just take a look at the schematic. Because again, I haven't really done much research, as you know. I just go on live, don't plan it whatsoever, and then I figure out what I'm doing as I'm going. So let me just double check that the schematic does show us what we want. So let me pull this up on screen for you in a minute. So zoom in and out. So this is the Mega Drive VA3 schematic. I don't know what VA we've got here. Don't know, but they're all generally the same for the video out, so the schematic will do. We're just looking for the video port. So here's the RF jack with video. Trace this back, up. Yeah, right there. So CXA1145, RGB come in. We're hoping these are the same values. That's the key. We're hoping that the voltage levels that come in on the Mega Drive 2 are the same on the Mega Drive 1. Otherwise, we don't really have a product that's a Mega Drive and Mega Drive 2 board. We'd have to make either 2 or like a dual resistor and some kind of blob. I'd probably just make 1 for each board if so. The RGB out on the Mega Drive 2 was just straight to the connector, so is that the same case? RGB 5, 6 and 8, yeah, straight to the port. So you can see these straight lines, they just go like the green goes straight across and in. So that just means there's a trace coming straight out of this chip. So green is say this pin, and this trace here comes out, down, all the way down through, around here, some nice trace routing there, down here, down to there, so this big fat trace, and then straight to the port. So we just need to cut the RGB traces or lift the pins out, or we could socket this for the sake of it. The idea will be what's the best way to install, so customers can stick it on top, solder 3 wires on the input, cut the legs or the traces on the output if they want to, or they can lift this out and put it in a socket and bend the output pins out. There's multiple options. It's whether the customer wants to cut the trace or not. Sync was straight to the chip, straight to the AV port, sorry. Just goes into the chip, up, yeah, and straight to the port. So it's looking the same as Mega Drive 2, basically. So I think the install should be basically the same. Don't think I'm missing anything. We've got audio that we can tap into as well. Well, we don't even need to tap in, that's already present. Yeah, so I think what we can do then, what do we recommend? Because there's going to be loads of revisions of this Mega Drive. And the only issue we have is we can do a universal guide which just basically says to lift this chip out, bend the legs out. That's the official recommended way. Otherwise, you're going to have to find where these traces go and cut them. The other option is you have to go on the back of this port and hope that all the traces are on this side. So if we wanted to do it this side, sharp on what we've done on the stream. We haven't changed the stream in a while, but probably how long ago was it? Probably about a week ago, I changed the capture card to the Blackmagic PCIe card instead of all of the USB ports. Other than that, I don't think I changed. Oh, and I changed this camera to 60 Hz, so now you've got like you should have a smoother motion on this top-down one as well. But yeah, you should get 1080, like, it looks crazy clear to me on screen. It has pretty much from the start. But yeah, maybe. I think we've been having internet issues because we kept dropping streams and stuff. So it's probably just been our internet maybe has been bad, and now it's picked up. It's good. Chip swap, not as such. We are fitting this little product I've made, the Mega Drive Clean RGB, to give perfect RGB output. I made this for the Mega Drive 2, then realised it's likely going to fit in the Mega Drive 1. So the plan is to basically see if that's true, because I've already got these in production, and I need to know rapid whether we can just rename this to the MD Clean RGB, or whether I leave it as MD2. So yeah, on the AV port, if I go to the wiki and I'll go to Mega Drive 1, and this is one of the main reasons I used to do this. If I wanted to flip over and find RGB pins, I'd hate looking for guides, so I made the guides for things like this, where we have the RGB pinout, looking into the console, because that's something else that nobody ever did. They didn't ever say you get a pin out of a Mega Drive port, and they don't tell you whether you're looking into the cable or looking into the console. So that's why I do real pictures. And then I normally do, which doesn't look like I've actually done on the Mega Drive for some reason, I could have sworn I had, is I'll do the PCB view. So if I go to, like, say, the Mega Drive 2, you'll see, like, there's the underside. So that would be the pins poking through the circuit board. So we actually do need to do a photo of the Mega Drive 1. Now, I could have sworn I've done that, but I mustn't have, because it's not in here. So we can use logic here, where we know this is ground looking at it, which means this is blue. And then bear in mind you're mirroring, so we're not mirroring in this case, because we're looking at the port here, which I can't quite get the camera up high enough to focus, but we're looking into the port like this. So if we rotate it around and down, then we are still looking left and right the same. So we know red, for example, will be on this side. So if we had ground here, then this is likely, there's 3 pins here, so we've got, move that out of the way, we've got 5-volt audio in red. So it's likely going to be 5-volt audio in red, is the presumption I'm going to make. So this is likely red, which you could follow all the way back to the trace and see if it goes back to where you'd expect. That's one way of doing it. Or you could use a multimeter. And then this side would be C-Sync, composite and green. So we really need to know the pin out of this. So I guess let me do that first, and I'm going to put this up for screenshotting. So I'm going to leave that there a sec, and then what I'm going to do is screenshot this for the wiki, and we're going to find out that pin out now, and I'm going to make notes. Because what I want to see is it easy enough to cut the traces here? Because people don't like lifting out. You want to lift out this chip, it's going to be a lot of work. People are going to prefer cutting traces, to be honest, I think. So we'll go for the cut trace route on this way. But let's just see if all the traces tend to be on the bottom. And looking at it, we clearly have the blue trace here, the traces on the top. The other 3 are there, the other 3 are there. So there's 1 trace on the top, and it's obviously going to be one we need, which is blue. So we know for a fact we're going to need at least 1 trace. People are going to have to find them, or we're going to have to get every single revision of Mega Drive and put that on the guide to show where to cut. So if I go into the port, sometimes I can do this with a little stabby stab on the end of my multimeter, so it depends whether this is going to fit in, and then you can probe in like that, and the middle one we need up on screen so I know which one I'm probing. So this will be blue, yeah, so blue is the one we thought. Obviously ground will be ground. Now red, which is this one. So red's the back one. I'll remember this hopefully when I come to write the diagram. The middle one is obviously the middle pin, you'd presume. That can't be that. We've already probed the other one. Oh yeah, back. Right, so back, middle, and the bottom is the centre. Right, so the 5V is the centre pin, which we wouldn't expect, and the middle one is the most forward, so that's audio, and the top one is the red. So what we have, and I better write this down because I thought I'd remember, but that's not exactly obvious. So top to bottom here, if I pull up this over the top, we have what we didn't quite expect, which was this one is red. So this is, obviously you can see the image as well. Nope. This one's red. This one is 5V, and this one's audio. So it's not the position you'd think they were in. So audio, red, 5V. So let me just make a note of that, and then I'll do a drawing after. So top right is audio, and then how am I going to write this down? Top right going down, basically audio, 5V, red, and then top left will be, you'd presume now the same order. So you'd presume at the top here, the fact that this top was audio, you'd think this would be composite, and then this, well, this middle one after composite would then be green, and then the bottom one would be C-Sync. So that's what we're going to presume if it's got the same, it's surely got the same layout as the other side of the port. So the top, which is in here, top there, which is C-Sync, is the bottom, which we expected. The middle composite we're expecting to be the top, yep, and the bottom we're expecting to be the middle. So we have composite at the top, then we have C-Sync at the bottom, so we have green in the middle, which would be correct, yeah. So that's the pin out. Top centre is ground, bottom centre is blue. Right, that's all the notes we need. So we've now got the pin out, and that's what I'll then make on the wiki. So next time we come to do this, we don't have to do all that, which is you know, quite annoying. You can just look at the wiki and find out where the pins are. So you can just come to this port, look at this port, and go, all right, I know where they are, basically. We are working on a Mega Drive 1. We're just fitting a RGB mod I've made for the Mega Drive 2, but I'm pretty sure it's going to work on this Mega Drive 1, so I'm just going to install this and test it. But I noticed on the wiki I don't have pinouts for the, when you're looking at these, you know, pins here, which ones are which in terms of red, green and blue and stuff. So we've just figured that out. I'm just going to move, again, I always move this camera over, but I'm just going to move this camera back over slightly, so the vertical is more in line with where I'm working. Right, so what we know now is, let me get red, green. I don't think I've got blue anywhere. I did have blue, but it's going to be red, green, and I guess pink in this case, just so I don't have to keep thinking where I'm going. Top right, so bottom is red, so this is red, for example. Green is middle over here. So actually, very easy when you look at that way now. And blue is now going to be pink, which is that one. So that's the red, green and blue pins. And C-Sync is yellow, and I've got no more colours. So let's maybe blow out the C-Sync trace, because that's the one we're going to have to cut anyway. So C-Sync is this trace here. So obviously it goes under the board, all around, up, over to a cap. I don't know why it goes up there. Where's the via to the rest of the board? And why have we got a cap on it? That'll be a 470 nanofarad cap, but if we cut the trace here, I can't actually see. It might be on both sides. I think if we cut that trace, this is the other problem with cutting the traces, you might have a trace both sides, This is going, all you can see is it goes from here over up to a cap. I can't see it going anywhere else. And it has to go back to the chips. So there has to be a via around here somewhere, or it's got to go on the other side of the board. So I can't see anything in that area. Can't see a via. Ooh, I just whacked the camera, yes I did. Good job it wasn't the one that was on. You can see here, quite clearly, the trace just goes to a cap and to ground. So this is one of the problems with advising people. If we cut the trace here, they're going to see this trace and go, oh, we'll cut it. But this isn't going to cut the trace, because then the other side of the board, which you can't easily see, somewhere in here, so somewhere down on, by this port, there's a trace running back. So this is why I'm thinking, do we recommend lifting this chip out? And it's not really a problem, because this chip is always the same. And I mean, I guess people could cut, what some people will do, which I don't like doing, is they'll just get the cutters and they'll just cut the traces to here, like cut the actual legs. But in terms of C-Sync, that's not going to help us, because C-Sync goes up, across, down. See, now it's meant to have a resistor. I can't see anywhere it even has a capacitor, so I think the schematic for a different version doesn't even show that capacitor, but yeah, C-Sync goes straight to the 5313, which will be, I'll zoom out a little bit. Oh, don't tell me I broke my little zoomy thing again. Oh, there we go. Thought I broke my zoomy thing. Goes straight to this chip. So the C-Sync's coming off this chip, so maybe we're more advised to cut the pin near here, because they're more than likely just going to come straight out. But basically, the idea is it's simple. I'm just trying to think of the best way to tell people, because there's so many revisions, what to do to make it universal and people don't get mixed up, basically. We can fix Amigas. I've just literally done, one's gone today, I maxed out one, and I've got another one right here to fix. Giant Amiga 500. If I hide the customer's details, we've got big Amiga 500 that's not that far off being worked on. So we've got that one to work on. I'll probably stream that repair maybe. I've done one pretty recently as well. Well, I've done a few. Yeah, that's what I'm thinking with the desoldering stuff. It's like, I know people aren't going to like if you give them a guide that says to take this chip out. As easy as it is once you know how to do it, it's not. I know people won't like to do that, basically. So I think we're going to look for a place that's much more likely to have a trace that's in one place and coming straight out. So C-Sync, well, yeah, C-Sync's here. And the other ones, I think for RGB, we can recommend, I think, cutting these traces, like cutting these pins, which are also difficult to do because these caps, I don't know, we're going around in circles a bit, because when you look at the revisions of these Mega Drives, these giant caps are always in the way. I'm honestly thinking we almost recommend, like, if they want to get cutters in there, we can. Like, if I want to get me cutters down in there, I just about can. You know, it's like awkward, but people are just going to go snip, snip, snip. So I think we just recommend either lifting this out, socketing it, or just cutting the traces. I think that's the option for the red, green and blue channel, those three cuts. The C-Sync wants to be cut somewhere over here and a wire added. So the other option is C-Sync comes into this chip so it can stay local. Let's have a look. C-Sync goes in to pin 10 of this chip. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not that hard to see. There's 3 pins here. I can't see a trace. Flip the board over and it's 3 pins on here. So if we then look at the 3 pins, you can see 1, 2, 3. So you can quite clearly see this is C-Sync here. So you could easily then say, right, cut the trace here and solder from here and here. It's a nice easy point to solder to. I think for any revision, it's fairly easy to see either the trace is going to come out of this pin, It's unlikely to go under and in, but I guess we could always do a guide. So I think we just find, I think the simplest thing is to find every single revision of Mega Drive, and I'll do a guide for every single one of exactly where to cut. I think that's the solution. Otherwise, I think this is going to be, you don't want the guide to be too complicated and asking customers to find where to cut. If the disc isn't booting on Amiga, is it the floppy? Not always, but very likely, yeah. It's a very common thing. Might not always be that, though. That camera's slightly out of focus as well. I notice that happens sometimes. Or is it my eyes? Am I out of focus, or are my eyes out of focus? This camera looks in and out. Ah, there you go. Yeah, it was out of focus. Right, so enough talk. I think what we're going to do is, I'll look at every revision Mega Drive 1, we'll find the best places to do the cuts, and that's what we'll do on the guide. So in this case, C-Sync is 3 pins down, it's this trace here, and we need to cut it going to the port is the key. So wherever the port goes, you can see from here, around, up, into there, this has got to go somewhere else. It comes off here, goes through, down here, and then goes missing, so I'm guessing it goes all the way over up to here. This will be a via, so I'm guessing this via here is C-Sync. Let me just check. And then when we come to do this, all we've got to do is blob wires on. So seems like a lot of prep work, but this is the key thing. I want to make the guide as easy as possible, basically. That's what I'm trying to do. Right, where am I? Here. So this is the one I'm thinking it will be C-Sync going to that main chip, and this should be C-Sync here. No, wicked. Is it going to here? Yeah, so we just mistraced. So that one does go to here, but it comes down through, and I thought these two, I thought this one went here, so maybe it's, yeah, it's not that one, so it's not there. So where does this one go? Another vanishing pin. Where's it gone? Yeah, I think you technically do have a VDP in a sense, but it's a combined chip, so there we go. So I think oh no, it's these traces. This one goes through here. See, it definitely does. It has this trace. So did I just follow it wrong? So it goes to here. This one, I think, C103. I think I mistraced the last step. Yeah, so this is the trace coming from the, not the CPU in essence, but the main chip on the back. So it'll be this 5313. So a good place to cut this would be on this specific one. I've lost it already. Was it over here? I think it's this one. So we could cut this trace anywhere. It goes up through, and what we need to do is cut it before this bit and after here. So we need to have one pin that, you know, connects to here and the other trace that connects to here. So we can cut it anywhere in between. So let's try and get back up close to where we wanted. So I think we can quite easily cut it just where we thought here. So that's what we're going to do. So that's going to be this cut done for the C-Sync. Just going to blow through this trace. There we go. And again, if I was doing this personally, and when I do these installs, I won't be doing the trace cutting. I'll just take the chip out and move the pins. But for the sake of people that want to install, I'll still recommend, obviously, you've got two options. But I think this option is going to be easier for most people. So I think this is like, we need to offer this as an easy follow guide, basically. Yeah, I'll offer this service. It might already still be offered already. I'm pretty sure it is. Let me check for you now. I'm 99% sure it's already available. Pull this over. And if there ever is anything not listed or mentioned, just ask me and I can get it listed. Pretty much everything you see me do is obviously work we do. Of course the site's been slow. I'll check that in a second when that decides to actually load. So we've cut C-Sync. Now we need to solder either to this pin and then to the trace here, which to be honest is pretty much what we need to do, I'd say. And the good thing is this pin, I think there's a point. Will this pin now go to the port or not? Because if not, we need to solder to the port. Yeah, so cutting the trace here, this is now the input for C-Sync, and this output actually goes to the port, so we can solder a wire to here, or to the chip on top, whichever we like. I'm tempted to put this chip on the bottom, to be honest, if it'll fit. So we'll expose this, because we want to solder a wire to that. And then the RGB output, if we get rid of that, flip this board over again. Ooh. Where are we? Over here. This chip here. Right, let me just check that now the site's up. Send and service. Bum, bum, bum. Mega Drive. Where is Mega Drive? Mega Drive 1. Yeah, we've got one on a service on the Mega Drive 1 called Video Output, Clean RGB plus SCART cable, and then you'll get the cable that this goes to as well. So we do offer this. Right, so the pins for the output we need to sever are this one, this one, and this one. We can see on top here, there's a trace here and a trace here. So these are the red and the blue, and the green must be the other side. So we might want to just recommend on this model cutting, oh, and of course the blue one's the other one. So the green we could cut quite easily, the green and red here visually, but the blue is the one that goes the other side again. So the blue is going to be the pain. I'm going to say, because this is blue, I want to say. Let me check the... Yeah, I'm pretty sure that pin is blue. So let me get the beepers out again. And I've got to do this for every single model to offer you guys a nice, easy guide, but... Oh no, it was green that we were going to struggle to get. Blue is the one we can see. We need to find green. Actually, that's... Oh yeah, if we're going to cut the port here, we need to find a place for blue, don't we? Yeah. So that is blue on here. Are we going to lift the... it's one thing I said about we can just... To isolate these, we can just lift this chip out and isolate the C-Sync RGB. That's what I'm going to do when I install. But I don't think many people are going to want to lift this out, so I'm going to look at every revision, find the place where we need to cut, which in this case we've just done one cut somewhere. So we've done a cut here to sever C-Sync, and we've got an input and an output now. But when I do them, I'm just going to lift the chip out. But this is to... I think it's much easier to find somewhere that customers can cut traces, because they're going to much prefer to just cut a trace than do this. Yeah, so that's blue. So red, green, blue. Is this the blue trace? Yeah, so that's the blue trace. So we can blow out, I think, the blue trace, and then we're going to have to connect to the port. See, no. If we take these out, we can connect straight to the pads underneath and not on top. Oh, this is a difficult one. It's going to make the install so much cleaner if we just take this chip out. Like it really is. Oh, yeah. I mean, it's not hard. Yeah, I don't know. I think we're going to have to recommend taking this chip out. Because if we don't, even if we find the places to cut the traces, you've either got to cut them right here, and then you've got where you're going to send your wires. So no. Complete change of plan. We're going to take this chip out, and I'm going to advise people to take it out. I could do a video or a guide still on these pins of how to find and locate them, of where to cut, but I think there's just way more complexity than needs to be when this install can be lift this chip up, bend the legs out and solder a few wires, and that's it, you're done. And then there's an option for people if they want to cut traces, and you know, we can find them. So to remove this chip, I'm just going to go straight above, avoiding these caps. Just literally hot air straight onto this CXA chip. Sometimes I'll go underneath near the end, but honestly you can just go straight on this chip. It's tolerant to the heat. It's no problem. We'll lift him out. We can desolder pump. I'm going to socket it for the sake of it. But you don't have to. You could lift the chip out, clear the holes, bend the pins out and solder back down. It's completely up to you. but I'm going to personally socket this when it's out. Yeah, that is Doom, or Mood as everybody says on the chair. I think you can only see that on the vertical as well, so when people mention the Doom chair, I know they're on vertical, because you can't really see it on the horizontal platform. So that just lifts out nice and easy. We'll get some desolder braid. If we're quick enough and it's warm enough, we can probably get this desoldered with desolder wick fairly easily. All depends how quick we are before the heat disappears on us, and then this can be more of a pain once the heat's gone. How much bigger the solders of these holes? So you can see we're already losing heat, and then it starts becoming difficult to clear holes. Yeah, and then you start needing flux and everything else. So this is why I use desolder pumps. I'm just going to desolder pump the rest. Well, actually, I might just warm it back up and do that again. Oh yeah, Doom. I played the. What's your take on the Doom 2016 versus the second one? So I think it was like Doom Eternal and then the one after that. I played the Doom Eternal first, thought it was ace. Played the second one, and I had to double check the dates. I thought I'd brought an earlier version. I just think the second one's like a cartoon, but it's like a love or hate. You tend to find people either love the second one and think it's way better. I personally just thought it was not like Doom at all. Just didn't feel like in any way it followed Doom's gore and style, and you know, just didn't do anything for me. What did I study? Nothing, I'm just self-taught. I can see me just desolder pumping these. Sod it. That's why you never see me use desolder wick. It's just so much easier with hot air and a desolder pump. Let's clear them out of the way. It was worth a try. And then we'll socket this in. Right, so I'm going to desolder pump from the other side. Zoom nice in so you can see something. So you can see how either shit I am at using desolder wick, or I just prefer hot air and a desolder pump. It's foolproof, basically. Right, so that's the hot air desolder pump. I drank all my coffee, who knows? Yeah, I personally like the Dooms when they're more, like I say, gory. That's my style for Doom. Am I scared the caps will pop? I kind of know the tolerance at which they'll probably end up popping. Happens rarely, but not that often. Just make sure you aim the air at the right place. And how much easier is that? No messing with desolder braid and irons and taking forever. And now our cut trace on the C-Sync is kind of irrelevant, because we're going to lift the pin, but that won't matter for the guide. This is more of a test for me. I can still show the guide, you know, capture the stream. So if we pretended that trace was still there, actually you might have to cut that trace. No, you will still have to cut that trace anyway, because it passes through, ignoring this pin. Does it? 1, 2, 3, we can actually check now. Because we never saw where that C-sync actually went. So pin 1, 2, 3, yeah, it goes there. So off, around, down to that dot, and then off, around, down to a dot by these 2 pins here. So I'm thinking it's this via here. So if this was the via, up through over to this via here, into these caps messy area here, and then off to the port. So yeah, we'd have to cut, we'd still have to cut the C-sync trace, otherwise it would run to the port still. So that cut is actually still necessary. And now we're going to lift the chip out, socket, and bend the RGB outputs out the way, and we can solder wires to the underside or top side, whichever. What solder pump? It's a completely worn off, but it's an engineer, and I don't know what it is. So if you just typed engineer solder socket, you'd find it. There's clones, which are made by, where have I seen it? Mechanic and Relife, I think, make clones now. But for example, this Relife one, I mentioned when you're desolder pumping, you hold like this. So you're desolder pumping, and your thumb rests like this, which rests nicely on this sharp edge. Whereas the original engineer, which is a Japanese brand, they've actually thought of that, so when you're holding it, your thumb's on a nice chamfer there. Whereas the clone, they've decided to make it like a knife, so after you've desolder pumped like 4 holes, it kills your finger. So stick with the engineer if you can, it's the original. That's socket. We want probably this one. Yep, that's the socket. So now, before we put this socket in, we've got to decide what we're doing. The input's easy, you just tap onto the input, but the output we need to tap back onto these pins, and that's it really, isn't it? We need to get to these pins. So all I'm thinking is we need wires. This is why I'm thinking we fit this underneath. I'm pretty sure we're going to fit this underneath, because we need to tap on the pins underneath there. But if we do that and flip this board, then the only other problem we have doing this is the pins for the inputs are here and the pins for the outputs are here. But on this board, if we were to fit it the right way, because it's expected to sit on top, the pins for the input are here, so you'd have to set it almost, you know, like here to go in, and then the outputs would have to go back over. So it's not the end of the world, but if we're going to install it on the underside, we've got to like place it here, do baby wires here, and do longer wires going over. I think that's where we'd have to do if we did that side. If we do the top side, welcome in. We're just doing the this Mega Drive 2 you saw us do the clean RGB. We are now trying to get it working on the Mega Drive 1, because I'm pretty sure it's going to work on the Mega Drive 1. But it's more of a technical challenge. We're trying to find the best way to do this easiest for customers. If we were to solder this on top now, which this would be the orientation, we'd have to get wires down to these pads of the socket, if we were to socket it. The other thing is we could just solder this in with the legs bent up, keep these in the air, and pre-solder the wires before we do that. That might be a better option actually, instead of socketing, and then it can stay on top. Yeah, okay, solder the socket. About the 7th change of this installation we've done. All we're going to do is bend the RGB legs out. There's no need to bend the C-sync leg out really, because it's just C-sync, but I suppose to tap on a wire we could. So we bend the RGB legs out the way. That's like that. We can pre-solder our wires now to RGB, and that'll go off to the AV port. For C-sync, we just might as well bend the leg out so we can attach a wire, and that will be our Which will it be? That will be our output. And the inputs here, we're going to have to pass through a hole somewhere to come back to the top. Yeah, that works. Solder sucker, the trick is just heat. Just literally plenty of heat and then pump when you're close. And again, get a silicon tipped solder sucker. Basically, that's like your key to it. The solder sucker, in terms of the ones that break traces, it's not this silicon tip one. It's this one here. That everybody always tells me when they see me desolder pumping holes with this, they presume either I don't know what I'm doing or I'm not experienced and they think they know better, and they advise to use this bag of shit, which everyone thinks is like, oh, you know what you're doing, you'll use this. This thing will eat through traces for breakfast. So the problem is the tip. The tip is boiling hot, it's what melts the solder, and it's pure steel. So you place that over holes, even if you don't move it, and then pump. When you have thin traces coming off holes, I've done it plenty of times to know, you've got a high chance of burning through that trace. No matter how delicate you are, it just isn't worth it. Just use a silicon tipped solder pump and hot air. You're way safer. Right, so I think we know what we're doing. So I want to also bend up. What pin was it? 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So third one up, which is third hole here. And I just want to have a hole somewhere to... Okay, I should have used my tweezers to bend the other ones up. That's way neater. I want a hole to pass this C-Sync output to, and we're even cleaner than the Mega Drive 2 installed. So that is going to end up getting reinstalled back into here. You can cut these legs or bend them right the way up, but I wouldn't tend to bend them past because they're going to be more likely to fracture. They just look a bit ugly sticking out like that, but it's perfectly fine. So if that's on, where's a hole? Can we just lift another pin? I'm wondering if there's another pin we don't need. We could be sneaky. Because this is not going to handle RGB anymore, let's lift up the red, and what we're going to do is pass the sync wire through there. So we're just going to use that as a little sneaky hole to pass through. Right, so what I want to do for the... because this is going to be used as a wiki guide as well. Let's clean my desk. And then I'll make a written guide for this. I'm going to show that like that for the guide. And we can capture that. And then what we'll do is we can install this now. But before we install, we want to solder the wires to here. Now the kit's going to come with red, green and blue wires and then gold wires, so I couldn't get any more colours, so we can easily indicate red, green and blue, but the other ones would be plain colour. So for this install though, for a photo, you're just going to see me using red wire. So we'll pre-attach some wires now and it'll all make sense when we're done. Do I sell low melt solder? No, I've got it though. I've got massive bars of it, which I brought from a factory, like obviously the main factory I use in China. So I've literally got like, I don't know however they are, but probably like 500 gram bars of low melt solder, which is probably, I bet it was £100 a bar. I think I've got like 10 of them somewhere lying around, unless I've chucked them, but I'm pretty sure I've got them. I just never really use it. So red, green and blue on the outputs, we are going to flood these holes like this. Tap on the wire, so it's going to become the red. I'm going to make them way oversized for now. Yeah, this is going to be nice because you're not even going to have wires going anywhere except straight in this area. So it's going to make this a nice, clean install, which is what we want. That's the red. I'll do all this and then find out the values are completely different on the Mega Drive 2, and then this would be kind of pointless because I could just redesign another board for make the install easy anyway. But logic dictates they're going to have the exact same RGB signals coming out of the chip. I really hope they do. but we'll soon find out. So this will be the red, green and blue outputs from our chip, and obviously the legs aren't going to touch there. And then we're going to sneak a wire through here, which we can do in a minute. And then we want the C-Sync input. Is it input? No, C-Sync output is here, so the third pin up. So if we flood that with solder, we will attach this wire here. And that will be this way. Ooh, nearly filled that other hole then. Right, so that's the output. Plenty of length. Is that output? Yeah, that's the output going to the AV port. Now we can solder the chip down. But yeah, to be honest, it is, because it's a tiny fan. So it probably is literally the exact same size as a server fan. It's due to the size. When they're small, they run at crazy speed. I've got a, funny enough, I've got a Blackmagic, is it Blackmagic? No, it's Unify. I've got a Unify switch. It's an older model, and that just has fans that run permanent even if it's not warm. And it's so annoying, because even if it's cool, it just runs 100% fan speed. So this will be, again, a photo for the wiki. So I'm going to straighten them wires, even though they're going to be colour-coded and thick. If I just straighten them up for the wiki image. Yes, where can I get this image from? I'll do this on the vertical. So, well, I can do it on there just about. Alright, there we go. So that's visual for the photo. And now what we do is solder this down in. But before we do that, we want to run one wire up through this little pin we've bent up here. So we're going to use that hole to poke a wire through. So I'm just going to get a bit of the red wire. We'll fish it through. It's just so it's in one place. So that can go through that via. Out the other side, and now we can find out where it is over here. This can now go to this cut trace, so this will become our C-Sync input coming from that 5.3 whatever chip name it was, basically the main chip that generates the video signals. So if we just cut that there, and I think this is a nice clean way of doing it. The only thing is you really need to lift the chip out. It's like definitely the best way, but if people don't want to lift the chip, they can choose to cut the traces. I'll write the guide so it's obvious what we're doing and why we're doing it, and they can either choose to, you know, find the traces and cut them, or they can just follow what we're doing. So if we do that, tap on there. Probably need a bit of flux, otherwise that looks a bit dry jointy. There we go. So that's now coming from the original source. We've cut the trace here, and then we've tacked a wire the other side of the board to this. We've snuck this through that hole, so now we have on the other side this little sneaky wire that is now the C-Sync input. And then there's the visual again. Now we've got the extra wires. Straighten these back up. There we go. So again, I'll screenshot that. Oh yeah, I'm normally on most days at 5. This morning I've had to do orders and everything as well. We've got people off at the minute, so I'm wearing about 7 hats today. You're lucky I'm even on stream. I've got to have food in like half an hour, so I kind of need to get this done ideally. Otherwise the missus is eating without me, and I'm going to be having just veg and no chicken. Evening, welcome in. But this shouldn't be hard now. We should just solder a few wires and then we're done. So we should make it in time. Best soldering LED. Best soldering LED. As in, are we talking about LED and you misspelt it, or an LED? These are insulated, so this red on here is insulation, it's enamel. So these can physically touch, they're not actually shorting. I burned the insulation off basically. So they're all the wires. Oh no, she tried to, but we actually didn't even go for a coffee today, that's how busy we are. So I'll definitely be going for 1 or 2 tomorrow. Yeah, I'm going to snip these legs slightly as well, because they've got a bit of bend on them where the factory have bent them, so... on. I've also got, funnily enough, a Costa voucher for 15 quid that I've had for ages, and I could use it every single day. And I still haven't used it, strangely, so I need to get that used tomorrow. Right, so that's sat down in here. You can see the wires sneak under the legs, so the legs are just bent up. It looks like they're touching, but this is insulation, so they're not making any contact with them legs. So long as these are out of the way, then obviously they are. They're not making contact. So now this chip won't receive the red, which it won't matter because we're not using the outputs. These outputs here are doing nothing now. The only thing I've thought here, that's probably not the best idea, because then you're going to lose composite. So I wanted to sneak it through that hole. We can't really do that, so let me bend that leg down, because you don't want to lose composite for no reason. So another quick photo capture there. Alright, there we go. So that's the legs you want to bend. All we need to do now is find a place to fish this wire through, because I forgot about that. You're still using this chip for composite. There's no point in losing composite. So you come back out of that hole. What other hole can we use? We might be able to fish it through one of these vias. And the thing is, the kit that comes with this, yeah, we can get this wire through here. But the kit that I've made comes with slightly thicker wire, so we could do with a thicker hole. Is there anything else we can take off this? Still getting C-Sync. Oh, you know what? I think we're disabling C-Sync doing this as well. Input, output. Yeah, we don't need to disable C-Sync though. We can solder that down, but that leads to this again, being soldered on. Yeah, if we just tack on the wire there. I'll tell you what we'll do. If we tacked on the wire, yeah. Change again. I told you I don't pre-plan these. This is how you know for sure I don't pre-plan these streams, because I literally figure out what I'm going to do as I'm going. The reason I'm putting this back down now is we want the C-Sync to still go into this chip so it can generate composite for us. Best soldering tin, anything with lead in, 60% lead solder is fine. Nothing that special about it. I personally at the minute use Solder King, but it's not something you can just buy. I used to be a supplier, or a reseller, whatever you want to call it. We used to sell Solder King, but we don't anymore. What we're doing, we are fitting an RGB mod to a Mega Drive 1. So this is the carcass, and we're fitting a little mod. I'm figuring out about 70 different ways to do it as I'm going, and then thinking of other things as I'm going. So C-Sync's going to have to be bent back down as well. So about the 7th photo of this chip, that, we'll wait for the stars to disappear. That's now what we want to do, just bend them 3. So C-Sync's easy enough. What we'll do is just solder onto the leg of here. That will keep it all composite. So let's get this in, because we know this definitely needs to be... actually, we need to also photograph that again. Should have probably pre-planned. There, so that's the screenshot to capture for them 3 wires on there. Let's get this soldered down so we can't change your mind again. He's in place. Flip over. Solder this in. So he's actually holding himself naturally there, so I can just rest delicately and get this soldered in. Evening, welcome in. For tools, I'll be doing, oh no, I've dropped him out. I'll be doing subscriber only streams where I go through all the setup and tools and what you need and how to do it. So if you want to learn that, just sub to be a member on YouTube or sub to Twitch. And after I've been away this week, when I come back, we're going to be doing a lot of sub only streams, and they're the kind of things I'll be showing you how to do this, basically, how to you know, make mods and invent stuff and how to solder and all that good stuff. Right, so we can solder all of these pins. Obviously the red, green and blue are already soldered the other side, so we don't want to reflow them. We don't want the wires coming off the other side. Right, so now, what do we need to figure out? Clean this up. Yeah, I was about to say, yeah, the course I'm on about, and I'm literally about to do it now. We've got everything set up. I figured the streams are just the best way to go for that at the minute. People seem to like the live streams. We've got a Discord Elite members chat now, so if you sub to the channel, join Discord and link your YouTube or Twitch to Discord, you'll be invited to a private chat. That's where we can have like the chat while we're on. If you wanted to share pictures or videos or anything else, we can use the Discord side of things for that. And then yeah, I'll be starting them on my way next week, so we'll plan it while I'm away, and then I'll be doing sub-only streams. Not just sub-only streams, but that's obviously I'll be doing them as soon as we get back. Right, so the only thing is now, I want to find a way to get this through the other side of the board, ideally quite short. This wire that I use will poke through these holes, but the wire that comes with the kit's slightly thicker. It's 0.3. Have I got my vernier on me? I haven't. It's like 0.3 mil. This is like 0.2, so it's going to be slightly thicker, and I don't think it'll fit through there. Currently, I'm on mods and repairs 3 to 4 weeks at the minute. We keep getting that many prestiges in that it's like a balancing act between prestiges and repairs. We are upgrading a Mega Drive 1 to have clean RGB, so like a nice clean RGB signal. So I don't think we're going to find a way to get. It's got a bit of popcorn in on the board there. Must have been from a while ago. That. I don't think we're going to find a place to pass this through with the wire that comes with the kit. I can't see anywhere. And I can't think of... Yeah, I mean, all I'm going to do is hope that the kit comes with... It's not the end of the world, it just means you might need a piece of wire with this kit, is basically the answer. I'm going to pass it through just this via here, for now. I think it's a moot point. We know what we need to do. In this case, this wire fits through. If the kit, when I get it, with the wire that comes with it, doesn't pass through here, you can just, use another wire and bring it around. All it means is you'll be short of one wire in the kit for the Mega Drive 1. I can improve that on the next kit, but this was obviously made for the Mega Drive 2. So we're good enough. Zoom out. Get a photo of that wire there as well now. And that's the red, green and blue and C-Sync. So we can now stick this down, and I think we're going to stick it on the edge like this. We need to solder to the inputs, which we didn't actually do, but we're going to solder to the pins here with wire. We want the ground as well, because I believe it was ground. Where is the pinout? Yeah, the top is ground, so we can go ground, red, green and blue, 5 volts at the bottom. So we actually need to attach 4 wires here as well. And again, bear in mind this kit is going to come with all the wires, so you don't have to pre-strip the wires to solder them on. That's the big part of this, like the time-consuming part. Near C20, is that like a hole we can maybe pass something through? Is that what you're referring to there? Why is that stopped? There we go. Running the streams, that's what we'll talk about, whether, you know, what time works best for most people. Can be any time, it's just whatever's going to work the best. For all the subs, we'll kind of come to an agreement of the best times to run them. It might be that I run them at different times, just so sometimes some people can get into the lives and others watch the VODs. All depends on the subs, really. Do I think I'll do a VPSP for the Mega Drive 1? Maybe at some point. I don't think there's any priority whatsoever at the minute, but I am focusing on Mega Drive 1 mods right now, and there's a lot of interest, it seems. So, all depends. Depends how well things sell, and obviously our main priority is like Game Gears and GBAs. We're always getting demands for things for them. Making the clean screen V4 and making the clean screen for the GBO, and you know, all kinds of things like that take priority. But this Mega Drive does seem pretty popular. Like, people are interested in the mods, which means there's obviously still room for improvements with the mods that exist already. So one more wire for the 5V, and we should be good. Love the chair, thank you very much. Nice little Doom chair. So 5V here, and I think that's every wire. Other than stripping all them wires now at the other end. That's why I always get these kits. If I'm going to do anything with kits that need wires and not flex boards, that's why I always get them pre-stripped, because I know how much time it saves if you don't have to strip wires. It's like one of the main tasks of doing a mod. It's the length of time to strip the wires. Right, so these are attached straight to the inputs as well. They're sharing the inputs. Straighten these up for a little photo. And again, I'll probably redo the guide when the official kit comes, but it's nice to have the option to screenshot. So we've got the three. Zoom in a little bit. We have the 3 wires poking under here, attached to the pads, and these are actually just floating in the air. We've got the 5V here, the red, green and blue, and the ground there, and this is the C-Sync poking up from the underside. So we've got the... Oh, actually, one more wire, C-Sync in here. Because this is the C-Sync out, I think. Oh, this is the C-Sync in. The C-Sync out needs to be on this pin here, so we missed one wire. And now that means the CXA chip receives all of the information it needs, the red, green and blue, the sync. We haven't changed the inputs. The RGB outputs are bypassed, but the composite output is still used. So this will maintain composite. We won't lose composite doing this, which is good for testing and also good for people that potentially want to stream RGB, like capture RGB to HDMI, while playing on composite if you're doing like streaming on gaming. And it's just another option. You don't want to lose a video output for no reason. Right, so that is now the quick photo for the stream, and that's all the wires. So all that's left to do is stick this down and solder the pads on, and we should be good to go. I'll just catch up on chat as well, because I think I missed quite a few. Subscription is like starts at £2, I think. Different prices. One thing we found out, a customer said they went on, I think it was Twitch, might have been YouTube. Literally on an iPhone, it's dearer than just using your Windows browser. So iPhone, obviously Apple are milking money off you. So don't sub on an iPhone, it costs more. Just go straight to the YouTube or Twitch. Are you using wire with flux? Yeah, the solder wire's got flux in it. You can use more flux, but you can see the joints look pretty sound, so I don't think we need flux in this case. Make the hole bigger. Are you looking at doing VPCB? You answered that one. Actually, we're not that far off. So near C20 was the only one. Where is C20? So many damn caps on this thing. Anyone know where C20 is? Give us a shout. C60, 30, 40, 70, 59. C24. 86, 32. Everything but fucking C20. Yep, can't see C20. Yeah, catch you in a bit. I won't be long when I've soldered this on, and then you can watch back, see if it worked. Hopefully it does. Glad to see you again. Yeah, thank you very much. I should be on streams most days. I'll be off all next week because I'm away. But other than that, yeah, I stream now pretty regular. Everyone seems to like it. Yeah, so again, for the before we go into the streams, this is, you really want to get on the Discord chat, and that's where we'll figure this out, like, you know, what tools you want in the beginning, so when we start the stream you can follow along. I'll figure it all out next week, so there'll be a lot of chat in Discord about that to properly figure this out, basically. This mod keeps the original socket, yes, so if your socket has all the pins for RGB, which this one does, so I presume all of them do, this socket's staying. We're not doing anything with it, and it'll still work with the composite as well. Right, so let's stick this board down. That's all the wires. This will be technically upside down like this. We need to attach these 4 wires, these wires. So really, we can stick it central if we wanted to, like this, as long as it fits. So let's just get some double-sided tape. Get this stuck down, soldered on, and hope it just works. So long as this is literally the same voltage as the Mega Drive 2 on the signals, we know this is going to work. I've actually got to change the resistors though, because we figured out this prototype had the wrong resistors on. It needs 13k. So the ones being produced will have 13k, so I'll have to tweak the resistors first. But you won't have to do that. This is just the prototype. So let's stick this down, and then we'll swap them resistors before I forget. We'll go to the top center, like that. Now let me just swap these resistors before I forget to do that, because that's a step I know I'm going to forget. And again, this is not something you'd have to do when you get the mod. This is... where are we? All the way over here. This is just because this is a prototype board, and I'm just going to alter the resistors myself. So let me just pull up the schematic. I'll get the resistors ready. 2. It's boiling in this room as well. Absolutely burning up. Might open that door. 13Ks. Anyone got any plans for the weekend? Yeah, on the live streams it'll be everything. So I'll be doing, obviously, because we've got subs that are then supporting us, I'll be doing all sorts on the streams. So it won't just be one thing, it'll be... I need my haircut as well. Getting massive. It'll be going through everything, so I don't think we'll have a structure as such. I don't think it'll start with being, you know, very formal, that we'll go from A to B to C and start with the basics, work our way through. I think it'll just be very casual like this. We'll just literally... I'll jump on stream because I'm on that often. We'll decide what topic we're going to talk about. If there's not that many people on at the start, which there won't be, you're pretty much free to ask questions, and it'll be very much probably just more like a just chatting to begin with and covering certain topics, but then we can get it more structured as time goes on, but I'm going to keep it just very open and flexible to begin with. Just literally jump on streams, pre-plan them a little bit of what people want to see, and then obviously we'll just go from there. There's absolutely no fixed structure at the minute. I've not really put too much thought into it. I think it's best just getting people chatting, and it's there that you can ask me questions that you think about that help you progress. Me teaching you a certain thing might not help you if you've got more questions about other topics, if you know what I mean. So it's going to be very much an open thing, I think, to start with. Yeah, this is a Mega Drive 2 clean RGB I just invented the other day. Works in a Mega Drive 2. I've sent it off to production and then realised that I'm pretty sure this is going to work in a Mega Drive 1. So I'm quickly testing it in a Mega Drive 1. If it does work, then it means I can rename the product before they apply the silk screen to actually say just Mega Drive, and we can sell it as a mod for the Mega Drive 1 and 2. So I'm hoping this works for the Mega Drive 1. We're just about to test. I've just got to swap some resistors because this is a prototype, and just before we sent it into production, I realised some resistors were wrong. So I'm just correcting. Let me just get this microscope up. I'm just correcting the resistors that are already going to be in the production version. So you won't have to do this step. This is just me. In fact, do I just move them out the way and use less light? This is just me fixing the board to match the prototype, like the mass-produced versions. There's just a few resistors that I've changed. So that will be second one up here. Needs to swipe off. Come on, warm up iron. So we need to swipe them off. Go on, just you. There we go. We need to swipe off third down. So just him. Not you. I'll tell you what. Hot air. Sod it. Otherwise we're going to lose the wrong resistor. Right, you go off. Oh no, mix the resistors up. Let me measure them too. I swiped him confidently and then they both decided to move, so tack him on there. Let's measure which one is. And we tack back on. Come on, solidify. Fine, you're going to be tacked onto him instead. There we go. Right, you move to there. Let me just measure these now because I don't know which one was the one I wanted to take off because they both moved. So one will be, or should be, one should be 2.8k roughly. The other one's going to be the 13 that we want to get rid of. Apparently that's nothing. What are you? What's going on? Why are my resistors, my multimeter measuring nothing on either? Right, you're 8.2, you shouldn't be 8.2. Oh yeah, you are, sorry, that's 8.2. So this one is the top one. Right then. So I might as well put the 13k on while we're here as well. So this one wants to go back where he was. You go back there. You come off. Get a 13k on. There we go. Put the other 13k on while we're here. And then the other ones we want to take off, I've now got to select again in the schematic. 1 second. So that one, that one, that one, that one. Right, so second one up, and then I don't know how many down, so he's got to come off. And then 1, 2, 3 up where there's a little gap, so 2, 3, this one, and then have we got enough 13Ks? Yeah, just about. Sound like I'm from Stoke? That's because I am. Tack on there. Last one, and then we can add the wires. So again, this is something you don't have to do. This is just a prototype board that I'm converting to the same as the mass-produced board. There we go. So that's now, unless I've screwed something up there, that's the same now as what the mass-produced ones will be. Yeah, sub through YouTube. It's sub through either, to be honest. Twitch or YouTube, your preferences up to you really. I'll be streaming onto both. Mega Drive all the way. Genesis I didn't even know was the name until I was literally running this business really. And no, I don't like the name Genesis. That's not a Mega Drive. It's definitely a Mega Drive. Right, so on this now, all we've got to do is solder these wires in place in the right order. And they should be, if I've done it right. Why is ground over that side? Because the only thing I've done wrong here, in a sense, not really wrong, but we don't tack off ground. Let's move this out of the way. Ow, hot. We don't actually tack off ground on, that's some double-sided sticky tape for sure. I've grabbed the ground from here, but the way the board's oriented, we're better off grabbing ground from this side, because ground is the same top and bottom as both ground, so this pin will move the wire over to, and we'll solder it back on. So there we go, that's the ground. So once more for the photo, I don't know how many times I've done this. To be honest, I'm probably going to have to do the guide again when it comes. Yes, sorry. I'll do the guide again when it comes, because we've made that many changes to start this video. I'm not sitting and watching myself on a 2-hour stream to figure out where to screenshot. I'll just we'll get this installed, make sure it works, and then when the mass-produced ones come, I'll make like a proper guide and do another stream. Yeah, well, like I said, we'll work out what stream time works best for most people. And I'll probably just vary it up as well. So some people that can never make a certain time, at least if we're varying the times, somebody can make one of the times at all points. Right, so he's back down in the centre. And now we can solder the wires on. So I've put the wires in order on the board that they should basically line up for the most part. So red, green and blue here should line up. They are red, green and blue, so we know this one is the blue here, this one is green, this one is red. So we'll tack them all into place. If I didn't change them resistors, it's just that this was a prototype board. I only made it like last week, and I've got something called the Clean RGB Universal, which is I've invented quite a while ago, that you can fit into any console, pretty much any retro console, and get perfect RGB. But you have to tune variable resistors to set the voltage correct. For dependent on what system you're on, what voltage it outputs. So I tuned it for a Mega Drive 2. Then I measured the resistors, but while they were in circuit, and then that literally looks like the joint, but this one's underneath. So that's the whole depth perception of a top-down camera for you. That wire is actually running underneath. Yeah, so I tuned the Clean RGB Universal to work perfect on the Mega Drive 2. Measured them resistors, but I left them in the circuit and never thought about it. And then made this board, and those resistors then were 8K, but they were actually 13K when I tuned it. It was just when you measure them in circuit, the way the circuit works is that the voltage then was slightly off. So obviously, as soon as I tested the prototype, I realised the mistake. Told the factory to just change them resistors and go ahead with mass producing because it works, other than the fact I got the resistor wrong. So you won't be able to get a board with the wrong resistors, but if I'd have just left this in, basically the output on the RGB would have been too bright. That's all that would have happened. Right, so this one now is sync output. So the only thing here is this one actually goes around, up, and over to that sync. So we've actually just about made that wire long enough. So let's get him on first, before the RGBs. There we go, so that's the sync output done. The sync input is this one coming up, so this can go across and up to here. And now we can snap that off, and again these are wires that are running underneath, not touching. It's just looks like they are from a top-down camera. Yeah, I'm well aware the SCART cable mods, they're not good. That's why I made this product. That's literally the reason I made it. So all the SCART cables that you have, they just mess the signal up completely. So they put AC coupling caps in to remove the DC offset, whereas we use a circuit here that removes the DC offset with no caps. That's why there's no caps on here. These are just decoupling caps. And then on top of that, to correct the voltage level on the output, instead of using 75 ohm resistors, they just put 470 ohm or 150 ohm, and they mess with the signal. The problem with using the different impedances is that composite and RGB receivers expect a 75 ohm load, so that when they put capacitors to filter out noise and other frequencies, they're expecting a 75 ohm load to make an LCR filter, like a low pass filter. So what I did because of that was I made my own cables. So these are literally made by me, designed by me, and a factory assembles them. Inside of here there's a white PCB with Retro 6 on. This is a straight through bare metal cable with double or triple, is it? At least double shielding. So every wire's got a shielding, then the whole cable's got a shielding as well. So this is high quality, complete pass through, no magic cable. And if you plug in an RGB signal that's correct, it'll come out the other end and work. So completely removing all that stupid cable magic, and you need an NTSC cable for this one, a PAL for this one. That's all bull. That's why I made this. Literally the reason I made this product. So this will be a DC output, pure RGB. You could connect this up to any system without any, you could solder wires straight to a VGA, straight to an RGB. You don't need any magic cable. This will be actual RGB signals being generated and passed to the port. So how it should have always been. But basically the SCART cables, they're good if you just want to pay less money and not mod. But if you want to do it right, then this is literally why I've made the Clean RGB. You can read all about it and see all the reverse engineering I've done on it and how I invented it on retro6.wiki. There's a ton of info in video standards section. So if you go to here, go to retro6.wiki, at the top there's this video standards. In here I've broke down everything, so people that want to know what your basically component info is, all the voltage levels, how they vary, all the RGB formats, because there's a ton of them. So I've figured out what all of them are, what all the sync levels are, what all the voltages are, composite, as you'd expect, how all that breaks down, including examples and issues, SCART pinouts, everything you need voltage levels is the key info that you need to know what real RGB signal should be. There's actually two standards, a PAL and an NTSC, but despite the names, everywhere uses PAL standards, even NTSC. There's a TTL variant as well. And then the clean RGB cables, this explains why the other cables are bullshit, basically. And it's not just me talking. If you know what Analog is, a massive company that invents chips, there's literally them explaining why you shouldn't use AC in video circuits. It's an old thing. You get things like this, which are field droop and tilt. You get other capacitive issues. There's nothing but issues with AC on video signal rails. I've shown all the issues with it in multiple streams and on things like the Neo Geo. But yeah, big info on there if you're that keen about RGB. But if you are after the best signal, then this is the whole point why I've made this product. This is pure RGB at its finest. So those will be the RGB pins. This is the ground pin. Oh, RGB moves down one. One to there, one to there, and one further down. And then we have the ground here. And this should then just work. This is the only thing we have to do. If everything goes to plan and everything works. Can I explain what this does? This is, I've kind of just gone over that in a reply to the other comment but basically it outputs what's called RGB to the video connector port on the Mega Drive, and it lets you use this things like the OSSC to get perfect video output, or if you've got things like a CRT with RGB inputs, which is usually a SCART connector, this is the best video output. This is basically pixel perfect. This is the equivalent in the 80s and 90s of HDMI. You get perfect video output. Composite, which is the standard, the little, I'll show you the cables at the end, the little yellow, red and white, they are much worse video signal. So this is just basically to improve the video output. I can show you the differences as well between composite and RGB in a minute. So if this works, you'll see the absolutely massive difference in video quality. One thing we might see on this as well, and I'm pretty sure we will, which I won't bother fixing tonight because I want to get some food in a minute, is when you make the video nice and clear with this RGB, a lot of these systems have issues with where they've run these traces, so where they run these wires, you know, all these traces. They tend to run clocks, like high frequency clocks, alongside these red, green and blue wires, so you get what's called things like checkerboard patterns, jail bars. You basically get noise on the video signal, and you can only see it in RGB because composite's that bad you don't even see it. So you might see this picture will be nice and sharp and perfect, but we might have some noise or jail bars that we can fix, and I will do. I'll probably just stream it tomorrow if we get noise on this. But ignoring that, that's like irrelevant to the RGB side. That's like an issue with the circuit board and its layout. It's not relevant to this, basically. What's the name of my haircut? Don't know. I've had it since I was like, well, very similar styles since I was sort of 17. Used to have highlights in it. I've had red hair, blue hair, grey hair, all sorts. Shaved at the sides normally now. I used to have it spiky everywhere, but it's due a cut on Saturday. But I won't be back on stream then for another week because I'm going away on Monday to Friday. But yeah, no idea what you call it. I'd call it old now. I think people are... Usually the comments are like, you know, get a modern haircut. That's normally the comments I get about my hair. Right, so I think we are ready to test, unless I forgot something. Console goes that way around. So I guess the first test is, does the console still work on composite? That's probably where we should start. So we have composite plugged in. Turn it on. Overlay that, is it? Right, so this should be exactly what we saw at the start. And bear in mind at the minute, it will also get noise. That doesn't help when you try and get a perfect signal and there's so many issues. This has got a clean power mod, and it expects the USB to output good power. This USB I'm using is a literally dog shit power supply over there, so you'll get some rolling hum, mains hum it's called basically. And Let's see if we actually get composite out. Looks like we've either lost composite or this thing just isn't capturing it right. No, so we've lost composite, so we'll have to check why on that. I think we've got everything we need on there. Or do we just ignore the fact we've lost composite for now, because I can figure out why after. Yeah, so let's ignore the composite then for the minute. I'll figure that one out. Let's see if we've got RGB. Because if the RGB isn't working, it's a sign we've maybe soldered something wrong somewhere. 5-volt rail not soldered, that would be why. Maybe. Oh, well, that wouldn't be why. Unless our chip's loading down the RGB, that might be what it is. Where is the... Oh yeah, 5-volt wire is literally floating in midair. So we have this wire we didn't bother connecting. This one goes to there. That might be why we didn't get composite, because then the inputs to this would actually power these chips, and they'd potentially pull power off the RGB. But I think the more issue was it was pulling power off the sync. Oh yeah, that's the issue. Because this board isn't running, the output sync that goes to the CXA underneath here now, this sync is coming from our board. Our board wasn't running, so this chip wasn't getting sync, so that was the issue. So yeah, good catch there. Come across me on 2 other profiles. Yeah, we're streaming on TikTok, Twitch, YouTube, Facebook, so maybe there. TikTok's I'm just streaming on one. There's only one. Retro 6 UK, is it? Or is it just Retro 6? Let me type it in. I never remember, because some are Retro 6. Yeah, it's just Retro 6 is the official one. Why, we've been spammed already, and other people stealing our stream by chance. Right, so this back up, that back over. So that now, hopefully, that makes sense why we wouldn't have seen it. You can add HDMI, but if you want an HDMI, all you need to do is pass it through this. So if you get a OSSC or similar, you can pass RGB into here and get HDMI out. So this is literally what's about to show on stream. When I put the capture card here, the HDMI, up on stream, it's going to be our cable plugged into here, RGB, and coming out HDMI. You tend to, my personal preference is you mod your retro consoles as RGB, so that you can then plug them into real CRTs like this with RGB. So I've got an RGB cable down here, an input, so I can play my RGB output on a real screen, and if I want HDMI, I can upscale it through an OSSC. If you mod it for just RGB and you lose all the others, then you've not got the option to play you know, on a real CRT or a real device that has that input. So my personal preference is to do RGB mods and then use an external upscaler. Right, so this should hopefully give us... Ooh, no, still not. Was that just failed to... Yeah, Sega. So we still don't have sync. Okay, so let's ignore the issue with composite at the minute. We can look at that. Let's see if we get RGB, because that'll give us an idea whether things are running right. And we may just have got some pin or something wrong on composite. I don't think we've got anything that we've disconnected that would cause an issue. So that on there, turn that on. No, so we have a sync issue. Oh yeah, you won't hear anything booting because it's not running on that. So yeah, we've got a sync issue. Let's have a quick scope then, see what we've done wrong. We may have, I know what we might have done. We might have cut the C-sync before the pull-up resistor, because I've looked on the schematic just, and there's actually there's a pull-up resistor on the C-sync rail. So we might have, where we've cut that trace, we might have cut through before the pull-up resistor, which is more than likely what's happened. So let's just tack on a ground wire for my probe. And I'm guessing we're going to see C-sync is just not right, basically. It's either that or the signals are completely off, or there's something wrong with this board, but the most likely culprit is I've probably just made that C-sync cut in the wrong place, I'm guessing. Pull up the scope. Yeah, for Pokemon save batteries you can do FRAM mods, it's called, instead of having the coin cell battery. I don't think it's something we currently offer, I just haven't got around to basically bothering to offer that at the minute. So let's do probe on here, 10 on here, and if I pull up now the scope instead, where's my probe gone? It's fell off. If we now power it up, we don't need the actual cable connected for this, we just need to see what's going on. Power this up, we presume this is running, so let's probe the sync in, and as suspected, no sync. So let's see if we gain RGB. Oh, we gain no signals at all. Or did I turn the console off, not on? Right, so there's the R, G and B. So that's the, well, that's the R, that's the G, that's the B. Sync is definitely not right, so yeah, that probably needs a pull-up resistor. That's dirty and not really syncy at all. And to be honest, we're floating as well. That's under 5 volt, under 0, so it looks like we've got floating AC on here. And then for that we're getting no output at all. G, no output. B, no output. I don't think we've got this wired right, to be honest. Ground should be ground. Yeah, something's a bit off here. Because we shouldn't be having floating signals. They should be correct. So we've got ground. We've got 5 volts. So why are we getting... Maybe these inputs aren't the same as the Mega Drive 2 then. 4.6. Is that the same as here? Well, that's how bad this power supply is for one. This USB power supply I'm using, it's outputting 4.6, not 5. But that doesn't really explain why we're getting like it might work and the probe's just not agreeing with me, but we're seeing under 0 volts. Look, that's under 0, which is indicating something's floating. But the main issue is quite clearly the sync is wrong. So I'm going to guess we've cut it without that pull-up resistor. So let's just ignore what we're seeing on the scope and chuck a pull-up resistor on. Just straight on top for now. So we need, let's just get, probably get a conventional resistor, just for quickness. If we even have one. And then they had a 2.2K, so let's get something similar. Let's go down and go to a 3K. So 3K should be something like. Yeah, you should see a VOD on YouTube. Basically, just go to youtube.com /retro6 /live, and this should be on permanently once we're done. After I haven't got long, to be honest. I'd need to jump off for tea before the missus kills me. So if this doesn't work, I'll probably carry this on at 5 in the morning tomorrow. I just want to quickly see if it's just a pull-up resistor issue, which I'm pretty sure it's going to be. If not, we will figure it out in the morning. hopefully that will make sync look like it should. Right, plug that in, turn that on, that's already on now. Does sync now look correct? There you go, sync's now correct. So we've definitely chopped the pull-up resistor off somewhere, which is no either, I'll figure that out. Pull up the screen then, let's see if we get anything on screen. Turn this on, tap the button. We've got a sync lock, now I need to plug in HDMI because it's not even plugged in. And I'm pretty sure you're going to see Sonic on screen. There you go. Bad news is that's not the right voltage levels. So, that's a shame. So we are going to have to make a mod. Yeah, we're going to have to make a mod for the Mega Drive one. It can pretty much be the same, but yeah, kind of a shame. So they do use different voltage levels basically between the Mega Drive 1 and 2. Just means I've got to make another. I'll pretty much make that board but and change those resistors, them 4 resistors. But it does mean I can look at making one that is maybe a bit easier to install on the Mega Drive 1. So has a bit more of an easy layout for these bigger chips, if you know what I mean. So, but at least we proved that it's right. And I could look to release it like that with different resistors on, but I think there's room for improvement on this layout. I don't know, what do you think? Do you think that would be a good enough layout? Ignoring that resistor, that wouldn't be needed. We could install it like this, and if I've got another spare one, I can quickly chuck on the one with the 8.25. Have I got one spare? Yes, here we go. So I've got one with the 8.25s on. So let's see if this is the unmodified one. Let's hot swap this over. And let's see if that's just the right level that we need. Like, out of curiosity, I could scope it, but let's just quickly swap the wires over. Because they're all in place, so we can hot swap this nice and quick. I'm not even going to bother unsticking this one. I'm just going to move these wires out of the way. It'd be funny if the wrong resistors for the Mega Drive 2 end up being the right ones for the Mega Drive 1. That'd be quite funny. Right, so they're in order, put out the way. Same for these, move them out of the way. He's just about long enough, so he's going to be fun to try and get on. And that's that. Sit him on top. Pretin these pads. So this would be almost how quick it'd be to install when you get the kit, because it comes with all these wires pre-trimmed. Yeah, I could do a switch, but the other thing we're fighting with is the physical constraint size of fitting these in, because I want them to fit all models. These are actually going to be difficult to get in because they're just about long enough. We're trying to fit them in all the models, and they really need to be pretty much this small to fit in. So adding solder bridges and stuff, it's going to get a bit tight for fitting them in. And it's no major feat to make 2 versions. It would just be nice to have one that just works on both. If I could fit in, these are already in production though as well, so pretty much I might as well make another version, because I've already got these being produced. So if they didn't work straight down like this, which they obviously don't, then I might as well just make another version that's specific to the Mega Drive 1, and like I say, lends itself to soldering onto the dip socket, not a SMD. Right, so that's all on. We just need to chuck that pull-up resistor back on, and we'll see what the 8.25 looks like. Ah, the joys of using normal size components. Fighting between the components staying on and the wire staying on. I'll attach wire to component like then, sod you. Alright, it's everything on. So now this is the accidental prototype that was the wrong value for the Mega Drive 2. Let's just see if that happens to be the right value for the Mega Drive 1. That would be quite ironic. Oh, there we go. It's looking pretty good. That looks pretty perfect. I can scope it and find out in a minute, but let's just have a look at Sonic. No, still too dark, so... Let's see how much darker it is, though. Let's see what the scope tells us. So, there... Let's have a look how far off the right value we were. See, there's something not right. Oh, the ground wires come off. Let me just grab that. There we go. So, this wants to be 1 point... actually, we're probably best unplugging the cable a minute so it doesn't load it down. This should be 1.4 volts between the two. So if we turn off and on and we wait for that Sega, then we know. Right, that's the Sega white screen. So now we can measure that perfect and we can see where we're at. So that should be 0.2, it's 0.182, not far off. 1.4, so we're not far off, that's 1.2 volts delta between them. We need to be up here. So that white line is where we need it to be. So it's probably going to be like a 6 or 7K, but I'll tune that perfectly. And either way, it's going to have to, unfortunately, be a custom, like another custom board. The Mega Drive 1 and 2 are different. So, no issues, but it just means I will have to design a board. And I'll probably design a board, in fairness, that sits maybe on the underside, taps into these, does something. I'll put some more thought into it. Running slow, we've got a 50-60 Hz switch here so we can make it run faster. But yeah, it's proven that they're very similar, but the Mega Drive 1 and 2 have different voltages, so that does mean we need, obviously, a different design. So, no big problem, like I say, it's not the end of the world. So let's put Sonic in, and we can hear Sonic running, and then we have, it should actually be, looking at the switch, if I've written it right, that should be the fast one, and we're in, I can tell you now anyway. Oh no, we are in PAL at the minute, we're in 50 Hz, so if I switch this, this is now 60, so that's faster, that's what Americans are used to. And then if I flick the switch in a minute, this is now UK speed. So UK Sonic, American Sonic. And I don't think Sonic runs, yeah, he probably does run faster as well. I was going to say the music definitely changes speed, but yeah, Sonic does actually run a bit faster. So I'll make a Mega Drive 1 specific clean power, and I better tell the factory to put that number 2 back on that board because I told them to remove it. Yeah, so anyway, that's it guys, that's all I wanted to do on this one. Test if this was going to work exactly the same as Mega Drive 2, but it does need its own little board, basically, for being Mega Drive 1, so that's it, and I will catch you guys probably, maybe early in the morning, but now I know I've got to design this, maybe later on, we'll see. I already have one with variable pots. It's called the Clean RGB Universal. So that's literally what this is. This is the first one I made, so this is fully usable in any console. The point of this one is so customers don't have to mess with pots, and it just drops in and installs basically. Yeah, right, so I will see you guys tomorrow.